We are an Italian private company, and we have been investing for more than 10 years in research, development, and production of bio-based solvent, namely for coating industry. Our know-how comes from previous expertise of our team in industrial biotechnology. As you know, many petrochemical solvents used in coating industry are quite hazardous, quite dangerous. So we strived and managed all this year to produce step by step a growing number of proprietary blends of several molecules coming from vegetal kingdom with the target of replacing as many petrochemical solvents as possible. So here you can see, of course, there are some general definitions about biosolvents. Worldwide, biomasses exhibit today a great potential for replacing fossil resources in production of chemicals. Recently, bio-based derivatives have been either used as green solvent or as pivotal ingredients to make some green solvent. So that means that the family of bio-based solvents can include today single molecules or even blends of molecules. Of course, the feedstock of these solvents are completely different from traditional petrochemical commodities arising from fermentation processes of carbohydrates contained in plants instead of organic synthesis. In this slide, you can see, for example, a comparison between maybe that before you have heard the very interesting presentation of BioAmber Canada about biosuccinic. On the right side, you can see an ester of biosuccinic acid. Of course, ester of biosuccinic is a very interesting solvent. In the past, it was produced by petrochemicals, so from crude oil, naphtha cracking, chemical conversion, and so on. Today, it's possible to produce it 100% from plant milling processes, fermentation, of course, quite modern fermentation, obtain the same molecule 100% bio-based. Just as an example, of course. Here, a little bit of biochemistry, but just one slide, don't be worried. Here you can see the processes, the anaerobic mechanisms with which plants can produce normally from carbon dioxide they absorb from atmosphere. As you know, by photosynthesis, they can produce, for example, glucose that you see in the center of the slide. And by different mechanism pathways, they can produce glycerol, lactic derivatives, and even some other chemicals. Some other chemicals, for example, here you have glucose, you can produce lactic acid derivatives, ethanol, of course, bioethanol, glycerol. But the most interesting thing now is that since in the past, this bioethanol, if we consider bioethanol, was produced from glucose extracted from edible plants like sugar canes. So, of course, in this case, there was the risk of depleting human food, no? Because sugar cane can be for alimentation of humans. Now is very interesting the possibility to hydrolyze enzymatically by enzymes cellulose, that is a polymer or carbohydrates that we cannot eat, of course, because cellulose is the material of wood of plants. We can enzymatically reduce cellulose to glucose, and then from glucose obtain, for example, ethanol. In this case, this ethanol is so-called second-generation bioethanol. And of course, it's not depleting food for humans, because we start from a material that we cannot eat. Do you understand? Cellulose is components for wood, so we can use wastes of wood, not more glucose. Eventually in question. Just an example, here from glucose, from glycerol. In this slide, I've showed you how many solvents. These are all are solvents. How many solvents you can produce from a very small molecule of glycerol that now is very widespread. That is very low cost because, as you know, is a byproduct of biodiesel production. So you have mountains of glycerol everywhere. And in the past, you were already be able producing the left side 5 chemicals like propandiol, propylene glycol, and some others. Since at the right side, I have shown you the new kind of bio-based solvents, the new generation of biosolvents coming from glycerol, glycerol carbonate, 2 kinds of isomer glycerol formyl, isopropylidene glycerol, and quite interesting, the last family of solvents, the so-called deep eutectic solvent. In this case, I have showed you glycerol choline chloride. That is a solvent, is a ionic solvent. I don't know if it's already sold, but it's already been studied at university and so on. So up to now, we have spoken about generally biosolvent. Now we start talking about our biosolvent. Our biosolvent of Liberty Chemicals Italy, are blends, are proprietary blends of different molecules, different building blocks, different bricks, like bricks we use coming from fermentation processes. They are chemically, they are different derivatives of carboxylic acids, or even some alcohols like bioethanol, of course, but even some other linear alcohol with a longer chain. The most important thing is the last paragraph, this last paragraph, because all our biosolvents that I will show you afterwards don't contain absolutely paraffinic and aromatic hydrocarbons. Of course, they don't contain chlorinated compounds, and they don't contain ketones. That is interesting because if you consider all products we have, so nowadays Liberty Chemicals is able for coating industry to replace. Here you see the products that are available today, but this list is growing continuously. Here you have, for example, you have toluene, you have xylene, you have white spirits, but our replacement that we'll see afterwards doesn't contain any hydrocarbon, neither paraffinic nor aromatic. Or even you have some ketones like acetone, MEK, MEK, MEBK, cyclohexanone. But our replacement doesn't contain any ketones because we start from green chemistry, so completely different chemistry that is coming from fermentation and not from crude oil. What is our know-how? What is our know-how based on? Our know-how is based on a sound and updated knowledge and a continuous experimentation, of course, on 4 pillars. The first one is experimentation on available building blocks, like some molecules you have seen in first slides, coming from fermentation, coming from vegetal oil extraction, like, of course, fatty acid methyl ester that has been introduced very well in previous lecture, from synthetic modification of natural ingredients. I showed you before glycerol, no? How many solvents can be produced, or quite interesting, from enzymatical modification on natural ingredients. Even, of course, enzymatical modification, as you know from chemistry, is now is preferred for many, because enzymes are natural catalysts. So you can obtain a reaction at the room temperature and with completely different, so no wastes and so on and so on. Second pillar of our know-how are many studies on compatibility among different solvents. because, of course, we have studied different solvents and of different solvents with several polymers and are resin used, in this case, used in coating industry. And synergy studies, because we have, during our study, we have realized that some solvents can have a synergistic effect in order to dissolve some polymers and so on. And last, in order to get the performance, and last, new application of already sold solvents. That means that we started selling a biosolvent for a certain application, and maybe afterwards we have realized that the solvent is suitable even from some others. That is, of course, interesting for our customer, for all coating industry. Flexibility. Flexibility is really appreciated, quite appreciated attitude we have. And I can explain you because, as you have seen before, a growing number of biosourced molecules are now available because there is now a growing interest from multinational group and from others. And like example I already showed you. But be careful. Singularly considered, many of these solvents have a lot of limitation in coating, as application in coating formulation. Why? Because many of them have too weak solvency power towards many polymers or resin. Some of them have too low or too high evaporation rates. They are too slow or too quick. And compatibility issues with other solvents or formulation ingredients. As you know, coating formulations sometimes are very complex. They include thickeners, rheology modificator, secative agents, pigments, of course. On the contrary, our know-how and our technological platform allow us to develop a very flexible product range, always fulfilling utilized requirements. And I have summarized this attitude that is very important, that is typical of our company. So our know-how, our technological platform, flexibility, and what is flexibility? At the bottom we have the growing number of requests that we get now all around Europe, but now we are starting even in the United States, if Mr. Trump will allow us to sell in the United States. We receive many requests, both from resins and polymer producer and from finished coating formulators. In both cases, we receive the request, and what is very important is this double arrow. That is, we have this attitude to interact positively with this kind of operator in order to tune and match the requirement they need. We will see afterwards which kind of request. Normally we start today, so far, we start a new project for a new solvent for a minimum amount, that means for a casted minimum amount of the partner of 10 tons per year, because, of course, for less than this quantity, we don't start the labor cost. And where, in any case, normally we sign a non-disclosure agreement. Mainly, we are working now with many multinational groups. Of course, we sign a non-disclosure agreement in order to protect reciprocally the confidentiality of information exchange. At last, which are these? What we have to assure really to our customer? Because, as you have understood, our products are not, chemically speaking, they don't have the same structure, of course. Our replacement of acetone is not acetone. Is another thing, is a blend of some other solvent. But we have to assure, of course, a lot of physical properties. First of all, very important, of course, solvency power on different polymers. As you know, solvency power can be is predictable by so-called Hansen solubility parameters, no? That is normally used, wide use Hansen solubility parameters, but we even use some further tools different from EHP. Secondary viscosity graph, I will show you afterwards. Viscosity graph is a function of polymer concentration, evaporation rate, flash point of the solvent. Of course, flash point and evaporation rate, as you know, are linked. Surface tension, film drying rate, the hardness of the film, many physical properties. So here is just a slide showing a kind of Hansen solubility parameters that you can see on the computer. Is a typical slide of viscosity. So as you can see, in this case, for example, here we have a curve of viscosity against the concentration of butyl acetate, normal petrochemical solvent, the same curve of our replacement of butyl acetate. We can tune and match absolutely as the same. If a customer tell us, so it's too low, too high, so we can match. That is quite remarkable. Huh? Wetting power, you know, has already been showed. This is really important. I see maybe that has been already showed today, but this is really the center of the concept of renewability. This is impossible for petrochemical. That is carbon neutral balance, because of course as I told you before, we start from plants that by photosynthesis are able to store sugar and starches, store carbon dioxide, transforming sugar and starches. We are using them to produce our biosolvent. We sell to coating producers. Of course, at the end of their life, even our products will be releasing carbon dioxide, of course, because they are chemicals that contain carbon and oxygen. But the very important thing is that, theoretically, even practically, this amount of carbon dioxide released by our solvent, by the part of our solvent, was the same that was removed by the plant. So it's the closed loop. It's a closed loop that for petrochemical products, in petrochemical products, you just have the right side. You cannot have this one. You cannot have renewability, because you can renew. You cannot sow and harvest petrol. You can just harvest petrol, but this carbon is fossil, comes from millions of years ago. You cannot sow any years. You understand? So it's completely different carbon. So some very quite impressive characteristic of our product. The consequences are that here you can see some petrochemical solvent we can replace. All our products as safety data sheet are just irritant. Here you can see toxic against irritant, toxic against irritant, toxic against irritant. All these are harmful, so middle scale irritant and so on. So just from toxicological point of view and labeling, this is quite impressive for all our customers. Secondly, biodegradability. All our products are biodegradable, more than 90% in normal European norm. Petrochemical are from 50 to 90, but be careful, many of them are very toxic for aquatic organisms. So theoretically, they have this biodegradability, but actually they kill bacteria or microorganisms in water. They should degrade them. That is typical case of D-limonene. D-limonene should be biodegradable, but it has the dyed fish pictogram, because it's very dangerous for water. So the consequences are the well-known consequence of all petrochemicals. The most important thing, last of all, so here there are some perception about the market, so we have no time now. Some motivation of many companies that are choosing now that are getting rid from petrochemicals and are considering now these new biosolvents. Of course, can be very different from company to company. Cost effectiveness is the last thing, last but not the least, because of course our products are very expensive. They cost, they are more expensive than petrochemical solvent because they are specialty, they are not commodities. And therefore any consumer, any technical, must try them, have to emphasize which could be the technical and marketing advantages that could be quite different. For example, that is, I just show you a picture. This picture is quite clear. Here you have on a metallic surface. On metallic surface, you have the left side. You have. I hope that the picture is clear. On the left side, you have a formulation containing as a solvent a couple of butyl glycol and xylene. And the right side, you have absolutely the same formulation, just dropping in the solvent, this couple of solvent with our bio-based solvent. So on the left side, you can see the typical defect of orange peel, and on the right side, you have a smooth surface. This is due to the wetting power. Mm-hmm. This means that the wetting power of our solvent, just changing the solvent, is much better. And of course, this is not free of charge. It's not free of charge. This is an advantage that can be reckoned. So this is all the summary of things I have already told you. Okay.